Hello everyone. Today we are going to discuss about double linked list. Uh, what do you mean by linked list? So far we discussed about linked list in the previous session. A linked list consists of nodes, where it consists of two parts, information part and a link part. Information part stores the information or data, whereas link part stores the address of another node. Okay, this is what we have seen. So we discussed about single linked list, where it consists of where the node consists of only one link. Now let's see about double linked list. So double linked list also consists of nodes, but each node consists of two link parts and one address part. Okay, two link parts and one data part. So if you observe here, so here this previous is a link which points to the previous node, and next is one link which points to the next node. Okay, so here I am going to store the actual data. So double linked list consists of totally three parts. So among those three, two parts are link parts and one is a data part. Okay, so uh, why we went to double linked list? So we are having single linked list. So what is the drawback of single linked list? Why we went to double linked list means, if you observe there in single linked list, we are moving from starting node to the last node. We are moving from starting node to the last node in traversing. While traversing, we are moving from first node, second node, third node, something like this. Okay. Suppose if you move to the third node, if you want to come back to the first node, it is not possible in single linked list. So we don't have the address of previous nodes. So that is the drawback. So in single linked list, only we can move in forward direction, but we can't move back. We can't move in backward direction. Okay. To overcome this drawback, so we got another concept called double linked list, where we are storing two types of links, where we are going to store the address of previous node as well as address of next node. Okay. Uh, so what are the advantages of double linked list? So there are some advantages and there are some disadvantages also. So we'll see the advantages first. So advantages, if you see pros, so we can move in both directions. We can move it in forward direction as well as we can move in reverse direction. So we can easily traverse from one node to another node. This is the main advantage of double linked list. Okay. Coming to the disadvantage, so there is some disadvantage for storing a single linked list. It takes a huge amount of memory. So in that case, for storing double linked list, so we need to store a lot of links. For that, the memory required is more. Okay. So when compared with single linked list, the double linked list requires more memory. So for storage. So this is the main drawback of double linked list. Okay. So where we are using this double linked list, we are having this double linked list. Where we are using it, if you observe our videos or if you observe our audios, you will be using rewind. You will be using rewind, and you will be coming back and you will be moving your video, or you are moving your audio. Okay, for using this rewind option, so we require this double linked list, where we will be moving in both directions, in forward direction as well as in backward direction. Okay, the main application is we are going to implement this double linked list in playing any video or sound files. Okay, now let's see clearly about this double linked list. A double linked list, uh, Okay, as I said, double linked list which consists of two link pods and one data pod. Now let's see the difference between single linked list versus double linked list. So if you observe this single linked list, it is easy to implement when compared with double linked list. Okay, so we can easily implement this single linked list. Why? Because we are going to store only the address of next node. We are not worrying about the previous node and how they are connected. Whereas in double linked list, so it is very difficult. We need to store all data. So for that, it is very difficult to implement this double linked list when compared with single linked list. Okay. And second advantage, second difference between this single linked list and double linked list is single linked list. As we are going to store less number of links, less number of addresses, we require only less memory. Whereas in double linked list, we require more memory. So we require more memory. So that is the drawback, as I already told you, for the double linked list. But if you observe the main advantage of double linked list over single linked list, it is given in the third difference. So in single linked list, we can traverse only in forward direction. So whereas in double linked list, we can traverse in both directions. We can move from back to front and front to back like this. Okay. So these are the main differences of single linked list versus double linked list. And then what are the operations? What are the operations that we are going to perform in double linked list? As we have seen lot of operations in single linked list, the same operations we are going to perform here also. So how we are going to insert a node in the list, how we are going to delete a node from the list, and how you are traversing, moving from first node to the last node, from last node to the first node. So we'll be seeing all those things. So in insertion, again, it is divided into three parts. So I mean, again, it is classified into three. So where we are inserting that node? Are we inserting the node at beginning of the list? Are we inserting the node at end of the list? Or are we inserting the node at a specific location in the list? Okay. So there are three ways of inserting the node into the list. Similarly, there are three ways of deleting the node from the list. Maybe I'm going to delete the node from beginning of the list, or maybe I'm going to delete, I want to delete the node at the end of the list, or I want to delete a node which is at some specific position. Okay, so these are the three ways we are going to implement while deleting a node from the list. And third one is traverse, where we are visiting each and every node in the linked list. Okay, next, let's see. Let's see the implementation. Okay, inserting at beginning of the list. Okay, so if you observe here, I have taken an starting and I have taken a node. Okay, if nothing is there in the list, if you observe here, nothing is there. So here I have given only none. That means list is empty. Now what I need to do, I have to link this node with this node. So for that purpose, so in place of none, I need to give the address of this new node. Okay, 8000 should come here. Okay, 8000 should come here. And what is this? So here I am going to store the previous node address. That means, so the address of this one will be stored here. Address of this start node will be stored here. Okay, if you see here, observe here, 8000, 8000. So like this, I am going to store. Okay. Uh, Here in this case, so as the list is empty, we are simply adding that new node to the starting node. Okay, starting pointer. So here in the second case, inserting at beginning of the list, if the list already consists of elements, the list already consists of elements. Observe here, Uh, so here, this is the first node, and this is the second node, and this is the third node. Now I am trying to insert this node, new node. Okay, where I need to insert? I need to insert at the beginning. So already beginning there is one node. Okay, with 21 address is 5000. See, our aim is to remove this link. First of all, I need to remove this link. So first, I'll remove this link. Then here I need to store the address of 8000. So here in the next part of 20, I need to store the address of 21. Okay. Observe this diagram clearly. This is the list. I'm trying to insert 20 here. This is my second thing. Okay. So what I'm doing? So here I need to insert now. So as I have taken new node. So first I'm giving the address of this node here. So here I'm just placing 5000. Okay. So I hope it is clear. Okay. Simply what we are doing is this node. So in the new node, here I am placing the address of this one. After inserting here, so here I need to get the address of next node. So next node is this one. So for that, I'll be giving the address of 21, that is 5000 here. Okay. So here I am placing 5000. Then next, what I am doing? So here I need to give 8000. So earlier case, here none is there. Okay. I need to give the address of my previous node. Previous node is this one. Okay. I need to give 8000 here. So it will looks like this. Okay. Then what do I need to do? I'll remove this, and this 5000 should point to here. Okay. So I mean, this start should point to here. I need to remove this 5000. Instead, I need to place 8000 there. Okay. Okay. See here. Start. I'm just placing 8000, and this is my new node. So in this way, I'm going to insert my node at beginning. Okay. It's a simple thing. If you go through it clearly, you will get a clear idea about it. Okay. Next, let's see insertion at end. So now I need to insert the new node at the end of the list. So here, if the list is empty, if nothing is there, if you are inserting at the beginning and if you are inserting at end, both are same. Okay. So insertion at end of the list. If this is my starting, so if nothing is there in the list, so whatever the node I am trying to insert, I am inserting at the end. Okay. So here, in place of none, I need to place the address of this node, address of 20. So here I will be getting 8000. Okay. So and I will give you a link here. So start 8000. So no none 20, and so as there is no node, so we'll be just placing it as none. Okay, or null. Now, suppose if there are elements in the list. So if you observe here, already 21, 22, 23. So these nodes are present there. Okay, now I am trying to insert this node 20. Where I need to insert? I need to insert at end of the list. That means I need to insert here. So after 23, I need to insert 20 here. Okay. So for that purpose, what I need to do? So here, after this, I need to add a new node. Means here I need to remove none, and I need to give the address of this node. So here I should get 8000. Okay. Observe here what I am doing. So okay, first thing, how we are going here directly. I don't know where is the last one. So that's why I'll start from my first node, and I'll move to the next node. Okay, first this is my I'll consider this one as temp. Okay, I'll check whether the next part is null or not. Okay, if next part is null, means it means that that is the end of this. Okay, here next part is not null, so I'll shift my temp from first node to next node. Okay, my temp comes here. Okay, so there I will check. Then my temp comes here. So here I got none. So that means this is my last node. Okay. So as I have seen, temp of next node is none. So I need to give the link to this node. Okay. So observe here, I have taken a new node. That address is placed here, 8000. Okay. So here what I need to do, in place of none, I need to place 7000. So I need to store the address of previous node. Address of previous node. Here I am getting 7000. So it is okay. Why? Because there is no other node. So I am placing it as none. Okay. So in this way, I am going to insert an element at the end of the list. Okay. Now coming to the third one. Okay. See, observe here. I have given 7000 like this. Now insertion at given position. Okay. So now I am trying to insert an element at some position. So if I need to insert at first position, second position, third position. So I need to take the position first of all. Okay. I need to take the position. Okay. If list is empty, so if I am trying to insert the element, so it will be inserted at the beginning only. Okay. So it is simple as we have seen in the earlier cases. So we are just giving the address of this new node here, 8000. Okay. Now let's see here clearly. So here in the list we are having 21, 22, 23. I'm taking the position where I need to insert. Okay, I need to insert this node where I need to insert at position 3. So this is first position, second position. Okay, suppose first, second. So here I need to insert the element here in between this one and this one. Okay, so I need to remove the links here. And so see what I'm going to do. First, I'll be checking where I need to insert. So until I reach the position, so I'll be moving my temp. First, my temp will be here. So I'll be checking that position whether I reach that or not. So as I have not reached, I'll move my temp to next node. Then I'll move to the next node. Here, I got the node. I got the position. So now I need to insert the thing, insert the element here. Okay, so I'm taking this new node. So in between these two I need to insert this. Okay, for that, so in the next part of 8000, in the next part of 20, I need to store the address of this node. Address of this node means 7000 should be stored here, and here 6000 should be stored. Okay, so that means, so we are just removing the links. Here what I need to store, instead of 7000 I will remove this 7000 and I'll be storing 8000. Okay. Similarly, here in place of 6000, so I need to store this previous node. That means 8000 should come here. Okay. So observe here, 8000 it is there, and here I'll change, update it. So here it will be getting 8000, and here in none in place we will be getting 6000. Okay. So in this way, I'm inserting my element at the given position. Okay. So we will traverse from first node to that position. Okay. First, we will consider this one as temp, and we'll check whether I have reached the position. If I have not reached the position, then I will move my temp. Okay. So in this way, if I reach to the position, simply there I am going to insert by changing the links, by changing the addresses. Okay. I hope it is clear about the insertion. Okay. Now let's see about deletion. Deletion, here also we are having three cases: deletion at beginning of the list, deletion at end of the list, and deletion at given position. Okay. So if you observe here, so starting with first one, deleting at beginning of the list. If the list consists of only one element, if the list consists of only one node, okay, so what we will be doing, we simply remove this link. Okay, so here I'm storing 8000 means, so there is one node here. Okay, if I remove it, here just we'll be getting none. Okay, we'll just remove that one. Okay, we'll be getting like this. Start. It will be changed to here 8,000 is changed to none. Okay, so if there are already elements in the list, if there are more than one element in the list, so here if you observe 21, 22, 23, here there are three elements in the list. Now I am trying to delete at beginning of the list. That means, so I need to delete 21 node. So if I need to delete 21 node, what happens? So the address of 5000 is stored here actually. Okay, if I delete this, so this should becomes first node. That means, so address of this 22, that is 6000 should be placed here. Okay, 6000 should be placed here, and here I'll just remove this 5000 and I'll just place none. Okay, observe here 6000 should be placed here. So then 5000 should be replaced with none. 5000 should be replaced with none, and simply I'm going to delete this. The next step will be like this. Okay, this is about deletion at beginning of the list. Okay, so next deletion at end of the list. Okay, so if there is only one node in the list, okay, this is simple as same as deletion at front. Okay, so what I will be doing, I will be just deleting this. I will be just deleting this. If I delete this, in place of 8000 I should place it as none. Okay, so I will be getting like this. So I just deleted my node. Okay, if there are already elements in the list, observe here, so there are already elements in the list. Now I need to delete the at the end of the list. So how come I know it is the end? I don't know how come. So how means, so I need to check the next node pointer. So for each node, if the next node point if I check that next node, if it is null, it is nothing but it is the last node. Okay, so for that, so first I will think this is my last node. So I will check whether it is the end. So if you observe here, it is not none. Okay, it is not null. So what I need to do, I'll move from this node to here. Now temp points to the next node. Then again I'll be checking temp of next. Is it none? Okay, it is not none. Again I'll move to here. Okay. So in the second case, in the third case, finally I'll be getting like this temp. Same as temp of none equal to null. That means, so temp of next equal to null. It means this is the end of the node. Okay, as this is the end of the node, what I need to do? I need to delete this. I need to delete this. In place of 7000, I should place a none. Okay. So what I'll be doing? So I'll just placing none and I'll be removing this. So you'll be getting like this 21, 22. So here I'll be placing a none. I'm just removing this. Okay. This is about deletion at end. Okay. Next, deletion at given position. So I'm asking the position. We will move up to that position and we will delete that node. Okay. So if nothing is there in the list, if only one node, so if you need to delete that node, the same thing, whatever we have seen earlier, here just will be placing it as none. Okay. So this is the thing. This is the important one. Here already there are elements in the list. So now I am trying to delete a node at position 3. That means 1, 2, 3. I need to delete this one. Okay, if I need to delete this one, I need to move from first node to second node to third node. First, I will consider this one as temp. So from here, I'll be checking whether I have reached the position. As position is 1, so I'll move my temp to this position. So then I'll be checking position equals to 3 or not. No, it is not 3. Then again, I'll move to here. Okay, so after reaching to here, I'll be deleting. See, observe here. So after reaching this, what I need to do? I need to delete this node. I need to delete this node means here I have given 7000. In place of 7000, I should give 8000. Okay. In place of 7000, I should give 8000. And in place of 7000 here, I should give 6000. Simply, I am going to delete that. Observe here. So I'll be getting 8000 here and I'll be getting 6000 here and I'll be just removing these two things. So finally, I'll be getting this. I just removed that. Which one? 23 I have to remove. I stored this one. Yeah, I just deleted this. I have given the links. Okay, so here I'm going to store the next node address, and here I'm going to store the previous node address. I simply deleted this. Okay, this is about deletion at given position. Okay, so then finally traversing. Traversing means visiting each and every node. Okay, here there are two types of traverses. One is I can move from first node to the last node, or last node to the first node. If you are moving from first node to the last node, we'll say it as traverse forward. Observe here. So I'll be moving first from my first node. So I'm considering it as a temp, as I already told you. So if that is not the last node, so I'll be moving to the next node. Okay, temp equal to temp of next. So until I reach to the last node, I'll be moving from first node to the last node like this. Okay. Similarly, traverse back means, so I start from last node. So from last node, I'll be coming back by using the previous addresses. Okay, by using the previous addresses, I am moving from back to the first node. Okay, this is about traversing backside, traversing from back. Okay, I hope you understand the thing. Thank you.